Hello everyone, I'm Elvis Bowie and I would like to talk about Bayes' rule. So what is Bayes' rule? Bayes' rule is a formula that gives the probability of an event based on new information that is or may be related to that event. So this is the formula for Bayes' rule. As you can see, we are given event A and B, which shows that the events are happening. PA line B shows the probability of A when B is true. P of B and A, line A, shows the probability of B when A is true, and PA and PB shows the independent probabilities of for A and B, for event A and B. An example that we have would be, so let's say event A is that the patient has liver disease, and B could mean that the litmus test that patient B that the patient is an alcoholic. So let me erase that real quick. So the patient is alcoholic. So, and then the past data of event A shows us that. So we'll say 10% of patients are alcoholics. No, I can't fit it on there. Oops. And then we have event B, which shows us that 5% of the patients are alcoholics. So 5% are alcoholics, and we'll just abbreviate that. So we might know that among those patients with liver disease, so 7% of them are alcoholics. So that is going to be the event. So B line A. So that would be the event B line A. So the probability that that event B has, which is that the patient is alcoholic, they have liver disease, which is 7%. So Bayes' theorem would tell me then that P of A line B, or the probability of A when B is true, as if we refer back to, if we refer back to this, which shows that the probability of A when B is true would mean that it would be 0.07, as the percentages would basically be converted to decimals, times 0.1, and then we divide that by 0.05, which should give us 0.14, or 14%. This shows that if the patient is an alcoholic, then their chances of having liver disease is 14%, which is a large increase from the 10% suggested by the past data. But it's still unlikely that any particular patient has liver disease. This is an example of how Bayes' rule is being played into statistics. But there are many other uses for Bayes' rule, particularly in machine learning in computer science. So in machine learning, Bayes' rule has its prevalence in computer science, particularly in machine learning, because Bayes' rule can provide a way to calculate the probability of a hypothesis based on prior probability. This can impact machine learning and AI, as the AI can be used to think ahead based on what steps the AI has already executed using Bayes' rule. This can also be used in data science, as well as new data can be quickly updated through the use of previous data that's already there, which makes predictions of certain events very easy to glean off of. So, an example of this would be we have some model. So, we have event A being a model or of some graph, and then B would be the event of some data. So given Bayes' theorem or Bayes' rule, we can glean that the probability of the model when the data is true shows, shows P of data model, and then P of, crap, I can't fit this onto the screen, model, okay, and then P of data. And this would probably represent some model or some data set as well. So it could probably be, for instance, weather or um or math, or some like math simulation where you have to crunch numbers very efficiently. So Bayes' rule does have its place in machine learning, but there's also another place where Bayes' rule also works, which is in Bayesian programming. Bayes' rule can also place into Bayesian programming, a methodology of programming that can specify probabilistic models and solve problems when less than the necessary information is available. One of its more common uses is the filtering of junk spam emails through the content of said email's words. And so this right here can also be a good example of Bayesian programming or Bayes' rule coming into play, because there would be two variables. So one of the variables, so we can have one being the words, so spam, and then the word, of the nth word of the dictionary is present in the text. So it would be W and sub n minus 1. And then so the n+1 binaries can also sum up all the information about an email. But then we start applying recursively to Bayes' theorem, we can glean that we can glean a little bit of information from knowing the probability of an appearance of a word, knowing the nature of the text is independent of the appearance of the other words, which does apply to Bayes' assumption as well. So let me write this down real quick. And then so we can assume, and then so we can take this, and then we can assume that the programmer can assume that, oh wait, shoot, my thing is gone, so P W1 W. So we can assume that this a programmer would use this to obtain something like this. So spam. Oh my gosh. So we can assume that a programmer can use something like that to obtain something like this. Oops, my iPad's about to die. But then there can also be a question that can also go into this as well. So let me erase this really quick. And then so we can put and then so we can also define this as and so a more example of a spam filter would probably be